Good evening, everyone. As in the last class, we had discussed how one can prove the component of a given vector is not a scalar physical quantity. For this, we had taken a radius vector whose x and y component in xy frame related to x and y component in x prime y prime frame. However, x prime y prime frame is rotated with respect to xy frame, keeping the origin fixed by an acute angle theta, and the relation was, look at the board. X is equal to x prime cos theta minus y prime sin theta, and y is related as y prime cos theta plus x prime sin theta. So, the relation had been derived in the last class with regard to a radius vector, but we may apply this result in any vector such as velocity vector, acceleration vector, linear momentum vector, angular momentum vector, force vector, etc. Say if we apply to the velocity vector, then only we have to replace in such a manner. Look at here, x is replaced by vx, y is replaced by vy, x prime is replaced by vx prime, and y prime is replaced by vy prime. So in this way we may apply this result in any vector. But today we are going to understand firstly the sign scheme of x component of velocity or y component of velocity or z component of velocity. However, we are taking firstly in one dimension and we take generally x-axis. So, the motion is taking place along the x-axis. Look at here. The particle is moving along the x-axis. Is the origin here. Now, just we are going to discuss right now the sign scheme of x component of velocity, say vx. So we have case 1, say vx is less than 0. Then what does it mean? It means that the velocity of the particle is negative? No. Velocity cannot be negative or positive. In fact, Vx is not negative or positive, but we may conclude what if Vx comes out to be negative. Say here, particle is moving along the x-axis, x prime, say here origin, so right of the origin. Customary we have taken positive, you may take negative, but here negative. Suppose particle is at the origin or left of the origin, say at peak, or right of the origin, say at Q. No matter where the particle is, If Vx comes out to be negative, then particle is moving in the negative x direction. Look at here, like that. This is the meaning of Vx is negative. However, Vx is negative, there is no meaning. But we conclude the meaning of what if Vx comes out to be negative. So, here case 2, if Vx is equal to 0, then what we conclude? We conclude that the particle is at rest either momentarily or permanently. Why? Look at here. Say the particle is at the origin or left of the origin, say at P, or right of the origin, say at Q. If Vx is 0, the particle is at rest either momentarily or permanently. Look at here. Look at this pen is resting on my palm, so remains at rest unless it is compelled by unbalanced force, till it remains at rest. Then we call it, this pen is permanently at rest. However, there is no absolute rest or absolute motion. Every one of the rest or every one of the motion is relative in nature. So, relatively, so I, with respect to me, this pen is at rest. Relative to me, if a person is moving, say on bike or say car or bus or train or plane, then with respect to that observer, this pen is in motion. So, that is why. But look at here, just I am throwing this pen, look at here. So, firstly, what you are watching, the pen is going up, and after certain interval of time, what we are looking, it is coming down. How is it possible? It is possible only when, if this pen comes to a stop and then started to move downward. So, here how much time? Answer is in no time. So, if we say no time, then it means that momentarily is at rest. That is why here either particle is at rest momentarily or remains at rest permanently with respect to certain observer if Vx is 0. Now, the last and third case is that case 3, look at here, say Vx is positive. What does it mean? It means that whether the particle is at the origin or left of the origin, say at P, or right of the origin, say at Q, no matters where the particle is, anywhere on the x-axis, then the particle is moving in the positive direction of x-axis. So, this is the meaning of, say, in one-dimensional motion, the sign of x component of velocity, that is Vx. Because we have to use this concept in the course of what we have taken is the concept of relative velocity. The concept of relative velocity. The article is going on. The concept of relative velocity. The concept of relative velocity. However, in one dimension, or in two dimension, or in three dimension. Firstly, we have taken in one dimension. What we had taken in the last class? We had taken trolley 1 and a person standing on the trolley 1, but he or she is not moving on the trolley. That is, with respect to trolley, the person is at rest. However, with respect to a ground observer, it is moving. Trolley is moving and the person is also moving. Say, trolley 1, person 1 in the positive direction of x-axis, say with speed v1. Now at some separation, here, some distance apart, trolley 2 and a person, say person 2. However, the person 2 is at rest with respect to the trolley, and trolley and the person 2 are moving in the positive direction of x-axis, say with the speed v2. Now, we are interested in the relative velocity of 1 with respect to 2. Here v12. Symbolically and by definition, we write velocity of 1 plus minus the velocity of 2. Minus means just we are nullifying the effect of the velocity of 2, and then it is added to the velocity of 1 by definition. So, just we are interested in finding the component. However, we have three methods to find the component of a given vector: by the trigonometrical method, or by the geometrical method, or by the positive axis method through small angle. However, we may apply any method. Look at by trigonometrical method. In trigonometrical method, what we do? Firstly, we have to take an angle made by the vector from positive direction of horizontal, here x-axis, in anticlockwise sense. But look at here, the trolley 1 and the person 1 is moving in the positive direction of x-axis. So, the angle made by this velocity vector v1 is 0 degree. So, here v1 to x comes out to be mod v1 cos 0 degree minus similar situation for the person 2 along with trolley 2 mod v2 cos 0 degree. So, it comes out to be here, say v1 taking as a positive minus v2. We all know cos 0 degree is comes out to be 1. So, it is v1 minus v2. So here case 1, say V1 is less than V2, then it implies that V12x is less than 0. What does it mean? It means the person 2 is on the trolley 2, sees that the person 1 along with the trolley 1 is going away from him or her. Going away from. Why? Because this is negative. So separation is increases as time goes on. Now case 2 here. Say V1 is equal to V2. This implies V12x is equal to 0. What does it mean? It means that the separation between person 1 and person 2, or trolley 1 and trolley 2, is not changing as time passes with respect to each other. However, for the observer, say sitting here somewhere else, so with respect to this observer, both of them are moving, but with respect to each other, they are at rest, because separation between them is not changing as time goes on, as time passes. That is why. So now here case 3, say if V1 is greater than V2, then it implies that V12x is greater than 0. What does it mean? It means that the person 2 sees that the person 1 is coming towards me, means separation decreases. So now an obvious question arises whether they collide or not. Of course, they may collide. Then we have to impose the condition for which no collision will take place. However, we will take the case and the problem in the chapter of the kinematics. But right now, we assume that there is no collision, or no collision will take place, and the separation somehow remains. Now only we have to conclude, what about if V12x is greater than 0? So this is in one dimension, very nice problem. However, you may take numerical values and you may construct the number of problems as you can please. So only by changing or direction changing, so both are moving in opposite to each other, and one moving in that direction, another in the opposite direction. There are too many cases may arise here. So this is the theme, or this is the, you may call, the main theory regarding. Generally people are speaking numerical, have to do more and more numerical, no much concern about the theory. That is, in my point of view, is not correct, because you may construct any problem by the knowledge of theory. So you may perfect your theory by exercising, by doing as many number of problems as you can please. So only the problem, or after solving the problem, you are strengthening your theory, you are strengthening your knowledge. So you have to do both. You have to concentrate on the theory, and as well you have to do a lot of numerical problem. Things that now we are going to take the concept of relative velocity in 2 dimensions. Look at here, in 2 dimensions. So to understand this, the concept of relative velocity in two dimensions. So we take an example. By the example we are going to understand. Look at here. So we have like two perpendicular junction. Say O is the junction. Now take it as north, south, east, west. Now say the person 1 starts moving from the junction, say with a speed v1 at 30 degree north of east. With a speed v1, say 30 degree north of east. 30 degree north of east. So 30 degree north of east. Customary, one can face some problem to draw this angle 30 degree. So there is a trick, however it may or may not be grammatically correct. So replace of with from. So 30 degree north from east. Speed v1. Now at the same time, from the same junction, the person 2 starts moving with the speed v2 at northwest, with the speed v2 northwest. If no angle has been assigned, then we mean that either of these two angles is 45 degree. However, their speeds are v1 and v2, but for convenience we take v1 is equal to v and as well as v2 is equal to v. So here v1 is equal to v, v2 is equal to v. Now we have to find velocity of 1 with respect to 2. This is by definition v1 plus of minus v2. Now we have two methods to find velocity of 1 with respect to 2, that is the relative velocity of 1 with respect to 2. Firstly, by the special method of two vectors. Look at here. Say we have two vectors, say vector A and say vector B. No matters in which direction these two vectors points. So look at here. So these two vectors diverging from this point. So the two angle will always form a smaller of these two taken as angle between vector, say theta. And the resultant passes through a smaller angle. You may perform the experiment and see in which direction resultant will pass through. However, there is a condition on theta. Theta belongs to close 0 degree to 180 degree close. Say resultant passes through, say here, making an angle say alpha. Now, what is the method? So we have to translate taking vector B as a free vector. If vector is free, then we may translate it parallel to itself without altering its magnitude and direction. So look at here. This is vector B. So these two are parallel and this one is transversal. So this angle is also theta. So draw perpendicular from here. So this comes out to be mod B sin theta and this comes out to be mod B cos theta. And now look at here, this angle is 180 degree minus theta. So you may apply cosine rule here, cos 180 degree minus theta. This angle made by the vectors A and vector B? No way. However, customary you may find such things, but it is not true. Why? A triangle cannot be formed by a vector. A triangle may be formed by its magnitude. So here modulus of A, here is the modulus of B. So this angle 180 degree minus theta formed by two vectors or magnitude of two vectors, mod A and mod B, the two sides of a triangle, and this is a resultant R. So this is written as vector A plus vector B, no matters in which direction vector A and B are pointing. In resultant, we have to write with plus sign. And so this is modulus of resultant R. So here modulus of A vector whole square plus modulus of B vector whole square minus this whole square is whole divided by twice modulus of vector A modulus of vector B. By doing proper calculation, we may find here modulus of R is equal to plus minus square root of modulus of vector A whole square modulus of vector B whole square twice modulus of vector A modulus of vector B cosine of the angle between vector. So as we all know, modulus will never be negative. So omit here minus sign and write with only plus sign. So this implies square root of modulus of vector A whole square modulus of vector B whole square twice modulus of vector A modulus of vector B cosine of the angle between vectors. However, customary one may say that cos theta, but here I am pointing that it is not worthy to say cos theta. Why? Because if we say cos theta, then it means that theta is ranging from minus infinity to plus infinity, say in case of Scalar trigonometrical function. We will take up in very detail in vector chapter. But right now, cos theta. Theta belongs to open minus infinity to plus infinity open. But here theta is the angle between vector. Keep in mind. So this theta ranging here 0 to 180 degree. That is why we have to say cosine of the angle between vectors. It is appropriate to say. So this is the modulus, but this is the direction. The resultant mixed with vector A. You may take with vector B as well, because it is not worthy to take, because if alpha is known, say this is beta, so alpha plus beta, this is theta. So no need to find beta, because beta is theta minus alpha. So only we have to find one of the angle of alpha and beta. So here tan alpha, look at from the figure, tan alpha is equal to what? This is the perpendicular and this is the base. So perpendicular here mod B sin theta is all divided by modulus of vector A plus mod B cos theta. So here, but tan alpha may be negative. Look at here, mod B, mod A, modulus may be different and cos theta may be negative, because cos theta may be negative in the second quadrant. However, sin theta is positive. No issue at all, but for cos theta. So tan alpha may comes out to be negative. Then how one can say, just I have told you earlier, right now, perpendicular over base. Why? It is not worthy to say like that. Because of the fact that here things like that of an acute angle triangle. That is why. So we have been derived in this special case, but it may be applicable if the right hand side may be negative. So it is a special case. So now in this special case, we may speak like that. So here, suppose here, case 1, say modulus of vector A is equal to modulus of vector B, then tan alpha comes out to be, after doing certain simple trigonometry, tan theta by 2. However, theta maximum 180 degree, then half of that maximum 90 degree and 0 degree. So in the first quadrant, or including 0 or 90 degree, so right hand side either 0 or positive, never be negative. So here general solution by trigonometry we will see later on, alpha is equal to n pi plus theta by 2, where n belongs to integer. But mind you, alpha is also angle between vectors. So the range of this alpha is close 0 degree to 180 degree close. So if we take n is equal to 0, then okay. Here if n is equal to 0, then alpha is equal to theta by 2. If n is equal to 1, then alpha comes out to be pi plus theta by 2. So no way this angle is acceptable in this physical situation. However, mathematically it is possible, but physically not possible because of the fact that alpha belongs to 0 to 180 degree. Keep in mind. That is why. However, it looks very simple, but we are focusing on the knowledge. So that is why we have to take every bit of that. So if n is equal to minus 1 here, then alpha comes out to be negative because theta maximum pi, so comes out to be negative. So also here look at the range, alpha is the angle between vectors. However, the resultant vectors and one of the vector A and B, so vector A. So alpha cannot be negative. So that is why n is equal to minus 1 also give you solution which is not acceptable in this physical situation. Okay. So only acceptable solution in this case is n is equal to 0, theta by 2. It means if the magnitude of two vectors are equal, then resultant bisect it. So these are the story. You may call it interesting story. So in this way, we have to take the things. We have to take every bit of that. Every point is important once you are discussing the things. That is why. Now we are in a commanding situation is that we are able to find V1, 2. So let us see how. Firstly, we try to find modulus of V1, 2. Square root of modulus of V1 whole square plus modulus of minus V2 whole square or minus V2. How one can get minus V2 vector? Only by multiplying with minus 1. Still we have some interesting thing is here. If we have vector A, if we multiply with by a scalar k, then resultant is a vector. Resultant is a vector. So we have to think of this vector, three things here: magnitude, direction, unit. Magnitude we have to take mod both the sides. Mod B. So mod of Ka, look at here. This is by the properties of modulus. So it comes out to be mod K, mod A. So magnitude becomes mod k times of mod a. However, sometimes we say k times of mod a, then okay, if k is positive, if negative, then there is a question. So if k is negative, no matters here, mod k times of that. What about direction? So case 1 here, if k is negative, then B and A are directed oppositely. Case 2, if k is equal to 0, then vector B becomes a null vector. You may take any direction because physically null vector has no significance. So if k is greater than 0, so B and A are in the same direction. What about unit? So case 1, if k is numeral, then B and A are having of same unit. Case 2, if k has unit, then B and A differs in unit. For example, acceleration is a vector physical quantity, multiply with a mass, and by second law of motion become force. So look at here, acceleration has unit 1 meter per second square, and the force has unit 1 kilogram meter per second square. However, you may call it 1 Newton. So these two have different units. So what about the scalar multiplication of vector? So just we want to find minus v2 here. Look at here. This is minus v2. Only after multiplying the velocity vector 2 by minus 1. So what about? Look at here. Minus v2. So modulus of minus v2, look at here, minus 1, mod of minus 1, mod of v2 vector, mod of minus of minus 1, mod of v2, 1 into mod v2. This is equal to mod v2. In very detail. Why not? Because just we are taking lectures for higher secondary physics students, not for undergraduate or postgraduate students. So we have to take every bit of that. That is why. So v2. So here minus v2. So this angle is 45 degree. So this is the quadrant type. So this is 90 degree, comes out to be 45 degree. So now look at the angle between velocity vector v1 and minus v2 vector, comes out to be here 75 degree. So here mod of minus v2 plus twice mod of v1 mod of minus v2, cosine of the angle between them here 75 degree. So this is v square, is also v square twice v because mod v2 is v and mod of velocity vector 2 is equal to mod of minus velocity vector 2, that is why also vv, and the cos 75 degree. Look at here. So twice v square 1 plus cos 75 degree. Look at here. So twice v square is 1 plus cos 2 theta, in fact 1 plus cos 2 theta. How one can say like that? Just I am going to increase one step here. 1 plus cos 2, 37.5 degree. Look at here. Cos 37.5 degree taken as theta, then 1 plus cos 2 theta. So it comes out to be 2 cos square theta. So look at here. 2v square. This is 2 cos square 37.5 degree. Now we have to remove the square root because everyone here 2 like factor, v same factor, cos 37.5 multiply cos 37.5, the two equal factors. So we have to write here mod 2 mod v mod of cos 37.5 degree. So just why mod has been imposed on 2 and v and cos 37.5 degree? Why? What is the need of that? Look at here. Suppose cos theta minus sin theta whole square. Look at here. And here theta is greater than 45 degree but less than 90 degree. Take it like that. If we are removing mod here, so as usual what the normally people are doing like that. So this is square, the square root. If you are writing like that, cos theta minus sin theta, then you arrived at wrong result. Why? Because here sin theta is greater than cos theta, because theta is greater than 45 degree but less 90 degree. But this is a square root here, because these are the real numbers, positive. So we arrived on wrong result. So we have to make a habit to writing with the mod. So if sin theta is more or less no matters at all, mod make the things real number, negative real number comes out to be positive because we have to add a minus of that. So we have now make a rule here, square root of x square, in fact x is belongs to real number, then you may write here a square root of x square is equal to mod of x, not x. However, if you write x, then okay, correct if x is positive. If x is negative, then wrong. If you write like that only, then yes, it is okay. When x is equal to 0, then okay. If it's positive, then okay. If it's negative, then wrong. So put the mod here, make it positive. That is why I am saying, taking every bit of that. If we are understanding the things, just we are going to deeper into it. That is why. So here, so that is why we try to make a habit to write mod. That is why, oh my goodness, 2 is positive, v is positive, cos 37.5 k2 angle, so it is positive. No need of mod, remove it in the second step, but write it in the first step. However, one can say this is the very quick examination, objective examination. So if we are doing like that, it takes more time. Then still I have a suggestion for them. Because keep in mind that this step in mind, and you write 2v cos 30, then okay. But this step must be in your mind. If so, then surely you are going to success in the examination, whatever you are going to face the examinations. That is why. So okay, so these are the positive numbers, so there is no need of mod at all. So 2v cos 37 degree. So here now we are in a position to write here modulus of v12 here twice v. So approximate value of cos 37.5 degree is 4/5 approximately. So it is comes out to be approximately 8v/5. So what we did for the magnitude, but v12 is a vector, so we have to think of direction as well. So here magnitude are same, just we have seen earlier some input between two vectors. So bisect here, look at 37.5 here. This is v12 direction, and this angle from horizontal. However, in our problem we have taken from one of the vectors, but here just we are showing as here 30 degree north of east or northwest. In this regard, just we are going to write here. So here this is 7.5 degree. So we want to write v12 vector. So here approximately 8v over 5, and we have to write direction here. Then 7.5 degree south of east, not east of south. South of east, it means south from east. South of east. So now we did completely for velocity of 1 with respect to 2, or you may say that the relative velocity of 1 with respect to 2. So these are the things here in 2 dimension. Now in the next class we are going to take some very nice problem that, so never try to miss the next class. However, if you are very well in this class, of course we have to do every bit of things with the curiosity, with great passion. In fact, definitely you are going to get success in your career. So hopefully you wait please for the next class with very nice problem, very interesting problem on this 2-dimensional relative velocity. Thank you.